about neutrinos, its properties, behaviors, and so on. The subatomic world is full of eccentric particles, each one having its respective properties, personalities, and behaviors. But one of them is very weird, very mysterious. This class of particles is called neutrinos. Neutrinos are the ghosts, the vampires of the subatomic world. They interact very less as compared to known particles. Maybe 700 trillion neutrinos are hitting you every single second, yet you can't detect or feel its presence. So you can see why they are known as the ghost particles. The idea of neutrinos was first given by Wolfgang Pauli in 1930 to explain the energy spectrum of beta decay. He theorized that an undetectable particle was carrying away the observed difference between energy and momentum of initial and final particles after decay. But the real experimental observation of neutrinos was done by four scientists in 1956, for which they were awarded with Nobel Prize. Neutrinos were detected by a nuclear reactor. But for this discussion, let's take the best nuclear reactor in the universe, the stars. When stars die with supernova explosions, their brightness reveals that of their entire galaxy. But all of their light is only 1% of the total energy liberated in the explosion, and the rest part of it is carried away by neutrinos in the cosmos. Neutrinos are tiny, almost weightless particles that travel near the speed of light. They are affected only by the weakest force in the nature, that is gravity, and one more, that is weak nuclear force. They are present everywhere. They fill the very space all around us. They can be found throughout our galaxy, in our sun, and every second tens of thousands are passing through your body. But there is no need to get alarmed, for these tiny particles barely interact with anything. In fact, they can even pass through entire Earth without being affected. One more reason why neutrinos are called the ghost particles is that you can't see them as they don't interact with light, but you can detect its presence in the proper arrangement. The original idea of neutrinos supposed that there was only single kind of neutrino, but it turns out that there are three different variants. One class of neutrino is associated with the electrons and therefore are called the electron neutrinos. The other two kinds are associated with the cousins of electrons, the muon and the tau, and therefore are called the muon neutrino and the tau neutrino. Scientists use lowercase Greek letter nu to indicate a neutrino, with a subscript to tell its kind. Most radioactive decay produces neutrinos in the process. So, for instance, if I had a neutron on the palm of my hand, after about 10 minutes, it will fall apart. It will decay. It will decay into a proton, into an electron, and the third decay product will be a neutrino, actually an anti-neutrino. And in this kind of decay happens in variety of naturally occurring sources in the universe. And in this way, neutrino is being produced all the time. Neutrinos, even being so weird and mysterious, are very interesting particles to study. New researches are still going on with advanced technologies to figure out their new properties and behaviors. But one of their property, their non-interaction property, led us to believe that they can be our information exchangers, which can take information to long distances without damaging it. So they can be the future of communication. Thanks you all for blessing me in the form of likes. I really appreciate you all for giving me your precious time. Please subscribe my channel and click the bell icon, and don't forget to select all options there.